So we're continuing topic 0.5, and in this video we're going to do examples 12 to 16. Example 12 and 13, we've really already done this, and we've done it pretty well with the coordinates. I'm probably going to kind of stick in that realm. The book wants us to use reference angles or reference triangles in this section, but I think we're probably just going to keep going with what we already know. So I'm going to go with sine of 4 pi over 3, cosine of 4 pi over 3, and tangent of 4 pi over 3. So this is good review. So let's find our reference angle 4 pi over 3. It happens to be here. I know that the x-coordinate is the sine and the y-coordinate is the cosine. So I totally said that backwards, didn't I? All right, the x-coordinate is the cosine and the y-coordinate is the sine. So my sine is negative square root of 3 over 2, and my cosine is negative 1/2. I know tangent is the sine divided by the cosine, so I'm going to put negative square root of 3 over 2 divided by negative 1/2, and this is going to double negative, is going to go positive, and then I know for a shortcut from the other day I can cancel those denominators, and then that's just over 1, so it's just square root of 3. In example 13, I'm probably still going to use my unit circle, but I do notice that 11 pi over 4 is not on my unit circle, so I'm going to have to find a reference angle or a coterminal angle. In over 4 world, I usually work with 8 pi over 4, so that's going to be 3 pi over 4 is what my reference angle is going to be. And then I know that I've got my coordinates there, so the sine of, technically it's 11 pi over 4. Is going to be the y-coordinate, which is square root of 2 over 2. The cosine of 11 pi over 4 is the x-coordinate, so negative square root of 2 over 2. And the tangent, just like in the last one, is the sine divided by the cosine. My sine is square root of 2 over 2. My cosine is negative square root of 2 over 2. And when we reduce that, we would just get negative 1. So in example 14, they give us, this was kind of our I can statement. So they give us the cosine. We know it, they tell us it's in quadrant 4, they want us to find the sine. So I'm going to go to the cosine. I know that the cosine is the x coordinate. So I'm going to go to the x coordinate. I'm going to go to the fourth quadrant, and I'm going to look for the x coordinate that has 1/2. That means I know I am doing the theta. They didn't ask me for the theta, but I know that that theta, the only place where it's 1/2 is at 5 pi over 3. They want me to find the sine of that angle. So the sine of 5 pi over 3, which was the missing theta, equals negative square root of 3 over 2. The next one is a little bit different. I would probably use triangles to get there. To see if I can figure this one out. So I'm going to draw this. I'm going to draw, I know I need a triangle in quadrant 3 because that's what they told me, where they told me it was. This is my reference angle. I know cosecant is the hypotenuse over the opposite. So I'm going to probably label opposite adjacent hypotenuse so I don't mess that up. So the hypotenuse is positive 13 because the hypotenuse can't be negative. So this has to be negative 5. I know I need to find tangent. In order to do that, if I don't know the triple, I have to do the Pythagorean theorem. So you might need to do Pythagorean theorem. I happen to know the triple is 12, and because we went in the negative direction, it would be negative 12. So the tangent of that theta is the opposite, negative 5, over the adjacent negative 12, which is going to go positive 5/12. And we're going to do one more here. So use the given value in the trigonometric identities to find the remaining trig functions of the angles. So I know that the cotangent is negative 3. So for free, I know that I get the tangent of theta has got to be negative 1/3. Okay. Now, I can't use the unit circle on this one. They didn't give me enough information. So I am going to try to figure out which quadrant I'm in next. So I know that tangent is negative. So if tangent is negative, that means I have to either be in quadrant 2 or quadrant 4. And then this is saying that the sine is positive. Well, out of quadrant 2 and quadrant 4, I know my sine is positive in quadrant 2. So I know that I'm in a quadrant 2 situation. So I'm going to draw my triangle in quadrant 2 with that reference angle. I know that cotangent is the adjacent over the opposite. So this is opposite adjacent hypotenuse. So adjacent -3 over opposite 1. I need to figure out the remaining trig function, so I am going to have to calculate the hypotenuse using Pythagorean theorem. So -3 squared plus 1 squared equals r squared. So 9 plus 1 equals r squared. R squared equals 10. The square root of it is just the square root of 10, and we know hypotenuse is always positive. All right, so the sine of theta is the opposite 1 over the hypotenuse 10. Or I'm going to flip it and going to rationalize in just a second. I'm going to flip the reciprocal, and then I'm going to rationalize so it's really square root of 10 over 10. Now I need cosine of theta equals the adjacent -3 over the hypotenuse square root of 10. And then the secant of theta equals square root of 10 over -3. We're going to flip it. And then I'm going to come back over here and rationalize my cosine.